Good afternoon, everybody. This is Diego Dave, and I'm looking at the Long Valley Caldera right now. So this is the caldera, this is the caldera right here. This is the whole Long Valley Caldera. As you know, Mammoth Mountain is actually just outside the caldera boundary, just outside of the caldera boundary. And if you look right here, is a resurgent dome. You have Lookout Mountain to your north, which is actually a volcano. So you could even see a bit of a crater there. This is the resurgent dome here. This is the central part of the caldera. This is where you're having more uplift. So you have a geothermal plant here, and that's Hot Creek there. That's to the edge of the resurgent dome. I'm going to show you right now on here. This is right here. This is actually right here. That's Casa right there. See? And that's the edge of the resurgent dome. So I'm going to continue driving. This is looking into the resurgent dome right there. So right here, this is the caldera itself. You can see complete, just flat grounds here. That's Lake Crowley. And most of the quakes that I've been noticing recently have been in this area here, just north of this lake right here, which is just north of Convict Lake. So it's in this area here. So it's just north of Convict Lake, and just to the and slightly to the west of Crowley Lake, which means this will put a swarm right in this region here, which is near the resurgent dome. Not over it, but near it. So based on this, I can definitely say that there we go, right here. And this is actually right in the resurgent dome. Boom, 6.0. And if I'm going to give you the exact coordinates of this, let's plot this into Google Maps. Very strong quake right here. And the center of that quake happened. This is taking some time to load. And yes, this earthquake happened right inside the resurgent dome. Let's see, right here, and so northeast of Mammoth Lakes, just northeast of US 395, south of Lookout Mountain. And this happened. Let's see. Lookout Mountain. Yep, inside the resurgent dome. Yeah, as bad as that is, a 6.0 hit right inside the resurgent dome, right where the highest area of uplift is. And they said that there's been 10 inches of uplift in those couple of years because of that earthquake, right after that quake. Huge amounts of uplift. In fact, that 6.0 I just showed you, let's go to recent activity. A strong earthquake swarm that included 4 magnitude 6 earthquakes. 4 magnitude 6. Not one, but 4 magnitude 6 quakes. So that wasn't the only one of them. Because apparently there have been 4 of these little suckers inside the caldera. Another one here, 5.4, that was 1983. Let's go to magnitude 5 then. Use this region, search. So now the base will be magnitude 5. And what's that? I only see one magnitude 7. Apparently this is the aftershock. It just happened inside the resurgent dome. And now let's go to magnitude 4 plus now. Okay, let's go to magnitude 4 and greater. For the same time period. Search. So now it's going to be 4 and greater. Right along this line. So all of the strong quakes on a line here. And the most recent magnitude 4 and greater quake. None recent actually. Oh, 97. In the Mammoth Lakes area too. 9.3. Let's go to searching again. And let's go to more recent times. Let's go from the year 2010. Let's see how many quakes we've had the last 9 years that were magnitude 3 or greater. Not very many, as you can tell. Small little swarm here. All in 2010. But that's north of the caldera, so that's along the near the Inyo craters. Good quake around 2016, but that's south west, so this is inside the caldera itself. And let's lower it to a 2.0. Let's go the last same time period. Let's go to from 2015 now. Search. So you have 4.0, 2016. Wow, that's a very strong quake. Very recent, only 6.1 kilometer depth outside of the resurgent dome area, because this quake happened let's see where this quake happened. This quake happened just east of the town of Mammoth Lakes, which means this quake happened in this area, which is outside of the resurgent dome. But to have such a big quake inside the resurgent dome is a very bad sign. Oh. So as you can see, this is a view from Lookout Mountain of Obsidian Dome and surrounding area of the Long Valley Caldera. So you have Deadman Creek Dome, and a resurgent dome, another resurgent dome, and and these are all volcanoes. And Lookout Mountain is a volcano and high point in the northwest moat of the caldera and outside the area of uplift associated with the resurgent dome. The central highland and many large calderas formed by gradual upwarping of the caldera floor after caldera collapse as a result of renewed magma intrusion. So of course, here's the thing, Long Valley hasn't erupted in over 700,000 years. It's having a very, very slow recharging of its volcano, very, very slow. Much slower than compared with Cinnabung, and Toba, because, they're related, actually. Most of the 400 meters of uplift occurred within the first 100,000 years of the caldera formation as magma intruded the underlying crust. The volcanic deposits, as a result, deposits part of the suite of erupted materials called the early rhyolites were also erupted in the first 100,000 years after the formation of Long Valley Caldera. Lookout Mountain was formed by eruptions from 670,000 to 677 to 692,000 years ago, and is an early rhyolite just outside of the area of uplift. I don't know if this means like 677 years ago or 677,000 years ago. Or it could be that means it erupted very recently. The top of Lookout Mountain is covered with obsidian and dark-colored rhyolite, high silica volcanic rock, which forms when the lava cools rapidly to a glass. Means the fact that it's covered obsidian is very bad, which means it has a lot of rhyolite in there. So let's see. Wow, this looks beautiful. Yep, and it's all volcanic. So, and there was an earthquake swarm there. I mean, some earthquakes are starting to form there today. There's also a pretty good earthquake in Yellowstone, I believe. There's one at 1.1 occurred around 10:15 p.m. Universal coordinated time. That was the one I noticed on the seismogram from Yellowstone. It was recorded in several seismograms. Definitely a volcanic tectonic quake, depth of 4.7 kilometers. I saw it on these areas here. It was a very sharp quake. Good sign of rock fracturing as magma rises, but it's only one quake. Let's go 7 days out, 7 days back. No quakes, magnitude 7 or greater. Let's go magnitude 7, all earthquakes, and see if anything's there. And looks like, yep, a couple quakes here. The strongest one being at 2.0. Maybe 2.4. There we go, 2.4. 6 kilometers deep. But Yellowstone hasn't really been too active. Long Valley, actually, even though it's older than Yellowstone in terms of eruptions, actually more active. In fact, this is Long Valley's volcanism recently. Earthquake activity. Good size swarm here starting to form. 2.5, depth about 2.5 kilometers mostly. Most all these quakes here at 2.5, 2.6 kilometers. It's pretty shallow, so likely caused by hydrothermal fluids. Maybe some faultal activity, but most likely hydrothermal fluids. Too shallow for magma. I mean, if that is magma, that's not a very good sign, but the fact there hasn't been any crazy volcanism, I mean earthquake activity like there has been in the 80s and 90s, that's a good sign. But the thing is, we're in a heightened state of earthquake activity and unrest since that 1980 incident. 1980 and 1983 swarm. So since then, it's been really active. As I believe that 1980 quake was caused by magma breaking rock and caused a major earthquake, as the pressure of the magma was too much and caused a large earthquake to be unleashed. Also, there's a graben in this area. There's fault. They found numerous fault scarps in this area too. So not all these quakes you see are magmatic. In fact, some of them are faultal quakes, and you could almost see like a bit of a faultal mechanism here. Faults and fissures in a long valley area. Yep. I want to see where the faults are. The area surrounding Long Valley Caldera and the Mono-Inyo craters, a volcanic chain is cut by a complicated mix of dozens of major north to northwest trending faults and down faulted blocks called grabens. The eastern escarpment of the Sierra Nevada along the west margin of the caldera has developed over the past 2.5 million years repeated offsets along a fault zone east of the Sierra Nevada, and the Earth's crust has been slowly stretching and pulling apart. This extension of the crust has resulted in a series of parallel valleys down faulted grabens and mountains that are bound by major faults. This is known as the Eastern region. The smaller faults within the caldera are related to the intrusion of magma beneath the Inyo craters, growth of the resurgent dome, and the formation of the caldera itself. Many smaller faults within the caldera. So like, here, I'll show you which faults they're talking about. Faults in here. It's like the 6.0 that occurred in 1980 was likely related to one of these smaller faults here. Alrighty, let's look at the resurgent dome right there. There we go, there's a resurgent dome there. Hey, I actually pointed that out in another video I made, but I had to delete that video. Yeah, there we go, is that fault? There it is, there's the resurgent dome there. I was talking about that. Here's that resurgent dome. And where's that Lookout Mountain? That's Lookout Mountain right there. I believe that's Lookout Mountain if I'm not mistaken. That's one of the domes. That's another dome. Dome, 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 and then you have the main resurgent dome right there. That's the caldera, and that's what you're looking at here is the resurgent dome. That's because of magma rising beneath the surface. And that's where you had the 6.0, you had it in this area here. Caused by one of those smaller faults within the caldera caused by magma rising. Alright, and since then there's been a lot of continued earthquake activity. The fault is that some of the quakes are here. See, but these are closer to the surface, so these could be fault related, some of these smaller faults. But some of these deeper quakes, 6.7 kilometers. That's probably the magma chamber itself. Well, thank you for watching. Have a great day. Oh, just before I go, I forgot to mention weather. I'm going to be checking GFS right now because I have to be going right now in a few minutes. So looks like, yeah, this is going to be mostly rain. In fact, the NAM has been showing mostly rain for New York City now, unfortunately. For those of you who want snow, I'm really sorry. I mean, there's going to be some snow in the onset for a couple hours, but then it's going to quickly change over to rain. There's sleet coming in, and then quick change over to rain, and then freezing rain, and might end as a very brief period of some very light snow Sunday afternoon as a cold air just crashes in. That's sleet coming in now. So we'll be getting a couple hours of rain. You know, snow, rain. You have snow, sleet, brief, probably very brief period of freezing rain, then rain, and then freezing rain, quickly changing over to sleet, and then ending as some light snow. No accumulation. But looking at surface temperatures, let's look at our 60 surface temperatures. 8 degrees. That's going to be extremely cold. Temperatures are just going to crash. Like, I mean, if this storm just goes a little bit further to the south, just say instead of goes here, say the storm ends up being here, just a few miles off. All these cold temperatures are going to be over New York City. We could be getting snow, sleet, and freezing rain. But if this goes further west, we might end up getting into the 50s. So very slight difference will make the difference between a horrible storm and rain. That's how much of the difference just a few miles of the track will make. But say the low pressure system decides to form here, right? And then goes off like this. See? You see this low right here? You see this area of this elongated area of swirl here? Say it doesn't really elongate. Say it consolidates in this area. You know, say it forms, you know, here instead of forming here. But of course it's going to try to form along the front. It's going to try to, what the models are suggesting is, because of the cold air damming, the low pressure center itself will reform, you know, in this area here and then go up the coast. But say it doesn't elongate like this. Say it forms a more concentric area of low pressure, more condensed, then you'll be having temperatures along the 20s for the whole storm. But the thing is, compare this to 6Z. I'm gonna go a couple runs earlier. Look at this, in the 20s. See a low pressure system right here. So I'm going to hour 40 right now. Of course, looking at hour 52 right now. Temperatures in the 20s. So looking at this earlier run, it shows consistent temperatures in the 20s throughout the course of the storm. Well, of course, that still remains to be seen, but very likely we're going to end up getting all rain. Thank you for watching. Bye.